Hello YouTube, and thank you for tuning in to yet another Hanging with Heavy video. We're going to continue on with our welding video series today as I show you how to recognize, identify, and write a variety of structural shapes. So, hang with Heavy as we get started with structural shapes. Alright guys, let's go ahead and get started. We're going to start with the most basic of our variety of structural shapes, which is an angle. Now, keep in mind that angle is W, T, L. The W is the width of the leg, and that's going to be in inches. This is the thickness of the leg. This distance here is going to be the thickness, and this is going to be the length of the material, the length of the material itself. I have leg here, but what I mean is the length of this leg, and that's going to be usually in feet. So W by T by L. Now this is how you will write this on your bill of materials. If you're an estimator, or if you want to be an estimator, this is how you're going to write it. If you're a welder fabricator, this is how you will identify it. Let's take a look at that. That could be like 1 inch by 1 inch by 1/4. And notice this little symbol I have here. Angle by 18 feet. Now, we use little different symbols, as you know, and in this case we use just a little L, and we consider that our angle symbol. Now, the legs can either be equal or they can be unequal. So in that case, you know, you would have your legs that would still be written the same, except you would have unequal legs, and you would specify that. Let's take a look at something else here. I have down here CRS or HRS. Now, we learned last time CRS doesn't remember, can't remember stuff. What CRS stands for is cold rolled steel. We are also seeing here that the HRS stands for hot rolled steel. And now it could either be aluminum or stainless or any other material that you can think of, this angle iron, but you would always specify it at the end. So I would order, if I called the lady or the man at the steel supply house, I would tell them I want some 1 by 1 angle iron, 1 by 1 by 1/4 angle iron, and I want that in a 18 or 10 foot length. If it was unequal, I would tell them I want some 2 by 2 or 2 by 3 angle, 1/4 inch thick by 20 foot long. So I would always specify what it was, and I would let them know whether I wanted it in steel, aluminum, or stainless. So if you're writing it out, make sure you put a little note onto the side as what it is exactly you want. Now then, let's take a look at this little illustration I have here of a piece of angle iron. You'll notice that the tops are radiused, and so is the inside of the leg. So you'll have a sharp outside corner, and you're going to have a rounded edges and a rounded inside. So if you try to put two pieces of angle iron together, they're never going to fit together properly if you try to put them in heel to heel. This is known as the leg. We call this the heel. And it's going to have a sharp outside corner. It's going to have a radius on the inside. And it's going to have rounded edges. Now, keep in mind, if you order aluminum or stainless, you're going to specify that on your print. Remember what we talked about up here. Cold rolled steel, hot rolled steel, aluminum or stainless. So, that's angle iron. Let's go ahead now because we're going to jump into something a little more difficult, and that's called a T-bar. So hang with Heavy. We're going to go do some T-bars. All right, ladies and gentlemen, here we go. This is a T-bar, and you can notice that it's a little bit different. The top part is known as the flange. All right, and then you're going to have the thickness, and we work with T-bars in the thickness of the flange. Now you're going to notice that the other part, the vertical part, is called a stem. And that is, we're going to call that, actually we're going to call that the width of the stem. And then we have the length. So we've got the flange, we've got the thickness of the flange, we have the stem, and we have the length of the material. That's going to be written as F times S times T times L. Let's take a look at what each one of those mean. All right, there we go. Now, like we said earlier, we are going to write this out as F times S times T times L. F is the width of the flange, and that's going to be expressed in inches. So that's going to be like a 6-inch flange. We're going to write 6, and then we're going to have the width of the stem. Now, I like to call that like the height of the stem or something, but they call it the width of the stem, and that's what we're going to call it here too. And that's going to be S in our equation. And then we're going to have T, which is the thickness of the flange. Now the thickness of the flange is what we're measuring here. Not the thickness of the stem, but the thickness of the flange. And then L is going to be, naturally, the number of feet or inches that we want this cut into. So if you were going to write it out on your bill of materials, or you were going to, you're reading a bill of materials, you might see something like 4 by 2 by 1/2 by 18 inches. You would know that 4 inches is the width of the flange. You would know that the 2 is going to be the stem, or the height of the stem, the width of the stem. The 1/2 is going to be the thickness of the flange, and the 18 is going to be the length in feet. And notice that at the end of it, we've got written T-bar. That's to help us, and that's to help the people we're talking to. So it's always nice to let them know at the end, you know, a 1 by 1 angle, 4 by 2 by half, 18 T-bar. Always put that in at the end if you can. Now, it's going to get just a little it's going to get a little deeper now. I hope you've got your thinking caps on and you've been following along. But next is channel. And channel can get a little crazy. So let's go ahead and put that up there and see what we can do with channel. All right, ladies and gentlemen, let's take a look at this one here. And this is our channel. Now, channel is a little bit different as we write it by D, by F, by T, by L. Now, D is the depth of the channel, and that's the distance from the inside of one leg to the inside of the other. But pay attention, because this is a radius corner in here. So the actual inside working area is right from here to here, even though this is the actual inside depth of the channel. F is the width of the flange, and you can see that written as either a decimal, a fractional type equivalent. F is the width of the flange. Okay, F is the width of the flange, and F is the width of the flange, and L is the length of the flange. So this is the width right here. This is the width of our flange. This is the depth of our channel, and this is our length right here. So let's take a look at it. You might see this written a little different as we go along. So I want you to pay close attention to what we talk about next as we talk about how to order and document a channel. All right, now ladies and gentlemen, I want you to pay very close attention here. This is extremely important. When you order a piece of channel iron from the steel supplier, whoever it is you talk to on the other end, man, woman, lady, or gentleman, machine, you're going to want to tell them exactly what you want. Now, most of the time, we can order it as this. I want a 6-inch standard channel, 18 feet long. That means the distance between here and here is going to be 6 inches. And you're going to find that channel iron comes pretty much standard if you order it. If you order this in 8 inches, this is going to come pretty standard. Now then, if you want something special, if you're asking for a specific type of channel iron, and they do make specific type of channel irons, you're going to tell them that you want a 6 inch by 1.5. This would be the 1.5. This would be our 6 inch by 170 pounds per foot. That's a heavy channel. That's every foot of that channel is going to be 170 pounds per foot, and it is going to be 6 inches from here to here. Now the rest of it's going to change. The thickness is going to change and such as that, but it's still going to be 170 pounds per foot. So channel iron can be ordered, and other steels also can be ordered in pounds per foot as well as standard sizes. Alright guys, now you tell me that was not a lot of information to absorb here. It's getting to be a little bit crazy with these different types of structural shapes now, so I hope you're following along. Now you know what I want you to do. I want you to like, share, subscribe, reach over there, hit that little button, so every time that you subscribe to the channel, I come out with a new video, bang, it comes right up on your channel right away. You can watch it on your device, whatever device it is you use. Now then, hanging with Heve, we're going to continue on with structural shapes, but next week it's going to get even crazier. We're going to get even more different types of structural shapes that you will encounter out there if you decide to become a welder or a fabricator. So, hang with Heve, and you know what I want you to do. That's right. Like, share, subscribe, but I'll catch you where? Out in the shop.